Hello, welcome back. In this session, we are going to look into thread synchronization using monitors. In the last session, we saw how to synchronize threads using locks. Now we are going to look into monitors. But before we proceed, let me just go quickly over the code that we saw in last session, because we are going to use the same code now. We have this account class which has private members ID and balance, and properties ID and balance to get those private values. Then there is a constructor taking account ID and starting balance as parameters and initializing its private members. And there is a member method called transfer, which takes a tuple of source account, destination account, and amount of transfer, and then it actually performs the transfer. There is a main method which loops 10,000 times and creates two accounts, creates two threads, starts the threads. Each of these starts take parameters. First parameter is for transferring $100 from account 1 to account 2, and second one is for transferring $200 from account 2 to account 1. Then we wait for both the threads to end, and then we print round number and the ending balances of the accounts. And we do this 10,000 times in the hope of not encountering a deadlock, or just proving that we don't have a deadlock. And if we have, we go and fix it. So before we proceed, let me make few changes here. This method transfer doesn't have to be instance method. It could be a static method, because we are not using current object anywhere. We are passing both source and destination objects and the transfer amount, so we don't need it to be an instance method. Let's make it a static method. And once we make it static, we need to change the qualifier here from the object reference to the class. So let's do that. Also, we don't need to create these accounts inside the loop. Let's just put the creation outside the loop. And let's just change these amounts from 100 and 200 to 100 and 100, so that we don't run out of balance in one of the accounts, because now we are not creating fresh accounts in the loop, we are creating accounts outside. And if we go on transferring $100 from 1 to 2 and 200 from 2 to 1, then account 2 will soon run out of money, and we don't want that to happen. So we are making both accounts same, so that both balance, both transfers same, so that the ending balance is always 1,000 for both the accounts, and these transfers will cancel each other out. So now our main thing that we want to do is we want to convert, instead of lock, we want to use monitor. Monitor dot enter. It takes a parameter which is account reference. It takes reference to any object on which lock is to be performed, and we are going to use the account object. So let's just copy this and let's put it here. And let's put semicolons at the end. We don't really need these braces, so let's just get rid of those. And let's just indent it correctly. Now, once we are done with the operation, we need to close the monitors, which is monitor exit function. And when we close the monitor, we need to pass the same parameter that we passed to the lock. And let's just build it. and let's run it. and it runs perfectly fine. Ran entire 10,000 times. So excellent, everything works fine, except there is a little issue here. And the issue is, what happens if there is an exception? Right now there isn't going to be any exception because we are not performing any task here really that could cause an exception. But what if there were some things here, some code here, which could possibly cause an exception? Then in that case, the control will jump from here outside the function and these exits will never get executed. And that's a problem because the logs that are acquired by the monitors will never be released and those accounts will be locked permanently. It will be interesting to create that scenario. So let's try to recreate that scenario here. Let's, just to recreate, let's just throw an exception. Sorry. Throw new null reference exception. Let's put this under try catch block so that the exception doesn't end our thread. We don't want that to happen. So let's catch it and let's just ignore the exception. So we are throwing the exception before we release the locks. So locks will never get released. And let's see what happens. And nothing happens. The threads are getting deadlocked. The locks which are acquired on those accounts first time are never released, and when next time we call this same method on another thread again, that thread can never acquire this lock. It keeps on waiting forever to get the locks and nothing ever happens. So that is the problem. Now the way to solve this problem is we put a finally block and we put this monitor exits copy this from here and put it into finally, and that should resolve our deadlock issue. So let's just build it and let's run it. Oh, that's because we didn't catch the exception. We accidentally removed that block, and since we are not catching the exception, the thread is causing the entire program to end. So let's catch it and let's build it and let's run it, and everything is again working fine. Actually, it's not really fine because we are every transaction is throwing exception and none of the transactions is really happening, but at least the threads are not getting deadlocked. There is one more problem here, and that problem is, what if the exception happens in the monitor enter? That kind of thing could happen if somebody calls, for whatever reason this thread gets aborted just when it was trying to acquire the lock within monitor enter. In that case, the enter will never complete and it will come out and lock was never acquired, and in that case we don't want to be exiting the locks that were not acquired because that will throw an exception. So there is one more parameter to this enter method that would come to our rescue, and that is called lock taken. So lock taken 1, let's declare this variable here, false. Let's just copy it and let's have lock taken 2 as well, and let's use that for second monitor enter. And before we call exits, let's check those conditions. So if log taken 2, because that's the one we are releasing first, then you release that log. If log taken 1, then we release this log. So we release the logs only if they are taken already, and then we run it again and everything is just fine. Excellent. I would like to bring to your attention here that what we have done with these monitors here is exactly same as what is done by logs. So log is just another construct over the monitors which internally uses the monitors exactly the way we are using them here.